So what I wanted to talk to you today about is this idea of democracy by design. Of course, my impression from the last week in Sweden is that you actually have quite a sane and rational government compared to the one that we have in the UK. So perhaps some of the things that I'm going to be saying here are not quite so pressing for you. I should point out this is joint work with my friend and colleague Josiah Ober, who's a professor of political science and great authority in classics, especially classical Greek, Athens. And so this is very much interdisciplinary work. So to begin with it, he told me the central question of political philosophy is this one: how can we live our lives together better? And of course, one of the things that we know with the digital futures, which I think you're all involved in, is this digital transformation to the digital society, which envisions this whole new range of interactive applications and digitized infrastructure. And so, in a sense, the question gets slightly modified to how can we live our digital lives together better? And what this means is that in all these sort of interactive applications and use of smart grids and smart water and smart transportation and smart cities, we still have this need for some form of governance and some form of collective self-governance to ensure three basic characteristics. So one of those is security, which you can think of as the sense that nothing bad happens. The second one is welfare, which we can think of as the sense that sort of something good happens. And the third one, which is the one we're going to focus on, is the avoidance of tyranny, which has various different forms. So if you let the computer scientist loose in the shelves of the political science, and you start looking at various political regimes that have been formed through the ages, it would suggest to you that democracy is the way to do this form of collective self-governance. And democracy is one person, one vote. So that's all we need to do, and we'll have these nice, fair, secure, welfare maximizing applications, right? And of course, you might think that, but as Alfred Nobel said when he invented dynamite, what could possibly go wrong? Right? Yeah. Well, let me give you a couple of examples. Yeah. So here's one. I would ask a question at the end of this. That's why it's labeled audience participation. But the audience is currently a bunch of squares over there, and I'm not quite sure how easy it is to get you to participate. So just tell the story. So there's this Republic of Absurdistan, yeah, and it has a parliament. And it's passing this new law. Okay? And this new law says the following three clauses. Yeah? So it says, a minister may by regulations make such provision as the minister considers appropriate if the minister considers that such provision should be enforced. Yeah? So this basically means a minister of parliament can pretty much do whatever he or she wants, right? However, it then goes on to say that regulations under this section may not impose or increase taxation or make retrospective provision or create a relevant criminal offence. Yeah? But then it goes on to say that regulations under this section may make any provision that could be made by an act of parliament, including modifying this act. So of course, one of the things that you can promptly do is that you can go back and you can change that second clause, for example, to say that regulations under this section may impose or increase taxation, of course. Yeah. So I've said that's the Republic of Absurdistan. So the question to the audience was going to be, this is a real country. Does anybody know which country this actually is? And so I'll spoil the suspense by going straight to the answer. It is in fact the good old United Kingdom. So this was our fabulous decision to withdraw from the European Union. And we passed this law the European Union Withdrawal Act in 2018. And if you can see on the screens, I mean, basically I've changed the order around, and they have, to be fair, put a what's called a sunset clause in this, which is to take it back. But you will see that it basically says what I said in the previous slide. You know, a minister can do what they like. You can make any provision that could be made by an act of parliament, but you're not supposed to do that. But of course, you could go back and you could change this legislation to your heart's content. So this was, you know, some kind of self-modifying legal system, which was being passed in a supposed democracy. And you could say, how did we get from this? It's just a small example, so to a larger one. Some of you may be well aware of this book, published in 1996, well, sorry, 92, I think, by Francis Fukuyama, saying The End of History. So we're saying after the Cold War and after the Berlin Wall had come down, we were all going to live in nice liberal democracies, and that was going to be the end of political strife as we know it. Yeah. But 20 years after the publication of that book, if you go and look on the shelves, as I said, you will see no end of books with titles like this: A Populist Threat to Liberal Democracy, How Democracies Die, The People versus Democracy, How Democracy Ends. Yeah. It's clear that this political regime is having something of an existential crisis. Yeah. So how do we get from there to there, and why should we then want to try and put democracy into our digital systems? And if we're going to try and do that, how do we make sure that we get it right? Okay. So we can see why it's still necessary. I'm just going to give you one example of a digital system like this. It's the idea of a community energy system. So we start off with a smart house, for example. Yeah? And that smart house has a number of appliances that it needs to power, but it may have a connection to various renewable energy sources. And if the amount of energy that it generated was equal to the amount of energy that it needed to actually power these things, then it would be fine. But unfortunately, sometimes the sun's not shining, the wind's not blowing, so you're not generating enough. And sometimes there is too much. You don't actually need all this. So, what do you do if you don't generate enough? You've got to make up the shortfall. If you generate too much, where are you going to put it? Yeah. So, of course, what you do is then you team up with another smart house, and you form a smart village, and then you still have the same problem. The village as a whole might generate too much or not enough, so you team up with others, and so on. And what we can see here is that there's at least 4 levels of interaction going on. There's the delegated level, where I just hand over control to my appliance and let them get on with it. Yeah? So a really nice example here is the smart fridge. You ask an AI researcher what's a smart fridge, and he or she will tell you that it's something that knows what's in the fridge, and it can start ordering things online for you to replace your milk. Yeah. Tell you when your milk's off, tell you what recipes you can cook with the ingredients. But you ask an electrical engineer who works on power system, their idea of a smart fridge. It's brilliant, because what you do, you can take thousands of these things and you can get them to coordinate their compressor cycles so that you can do what's called voltage control and frequency control, which you actually need to get the grid to operate properly, which is a brilliant example of a multi-agent system working perfectly. But us as users, we don't want to know any about that. Yeah, we just want to know that our fridge is going to keep our perishable products within a certain temperature range, but how they actually go about doing that, we don't care. So we're out of the loop completely. We just say, yeah, get on with it. At the next level up, there's a programmable level, where some of our programmable appliances, we can actually sort of say, well, I don't want my dishwasher to do it now, it can wait till tomorrow, same with my washing, yeah. So we can program it. We can say, yeah, as long as you're done by this time, I don't care. So you pick the best time when there's an excess of energy, when it's cheapest or whatever, and take care of it. Yeah? So I need to specify requirements, but to some extent, and letting the machines negotiate for themselves what is the best schedule for getting the jobs done. The next level up is interactive. I mean, suppose there isn't enough energy and we've got to switch some stuff on. Then I've actually got to get involved with the system, perhaps, and start turning stuff off so that we avoid a brownout and everything being switched off. And on the fourth level, I've actually got to make decisions. I've really got to be involved. I've got to pay attention to it because these wires don't just spontaneously install themselves. And the things on my smart meter don't program themselves and so on. So someone's got to make investment decisions about this thing. So I've actually got to pay attention and get involved in effectively the high-level governance of the whole energy system. But in actual fact, there's an issue of governance at every level, because these all have various forms of collective action problem going on. So it's quite easy to see where there may be free riding going on, or other common risk dilemmas involved in turning stuff off and so on. So we've got to do some kind of governance. We've got to pay attention to this issue. So how are we going to do this? Well, this is one of the theories of Josh Ober, basically. So it's what he called basic democracy. And in basic democracy, his concern was how it is that you go about designing institutions for governance which prevent the occurrence or recurrence of tyranny. Because basically he said there have been 3 occasions when this has occurred throughout history. So in the agrarian cultures of about 10 to 12,000 years ago, they were apparently highly democratic. In the Athenian democracy of about 400 to 200 BC, their primary concern was to avoid tyranny. And in what he called democracy 3.0, this was the liberal democracy that we call it these days after the, well, they call it the American Revolution. We call it colonial insurrection day, but I mean, perspectives, yeah. But the essential thing was that there they were trying to get away from a tyranny that was being imposed from outside. And this was the fundamental part of basic democracy. And this was distinct, he says, from liberal democracy, where the concerns for justice and values of morality, autonomy and rights of man and so on are also primary considerations. So in his book entitled Demopolis, Theory and Practice of Democracy Before Liberalism, he claims that basic democracy is a reasonably stable form of collective self-government. It can be put together by a fairly diverse group of citizens. It can be both legitimate and effective, and provides the material conditions for human flourishing, promotes free exercise of constitutive human capacities, and sustains the desirable conditions of social existence. And this is what we want to live our lives together, right? And he says, the features of this are such that it's not morally committed, nor even opposed to value neutrality, human rights, distributive justice based on egalitarian principles, distribution, and so on. He does say that to achieve this stability and legitimacy, you require rules. Yeah? And these rules have got to restrict the absolute tendencies of the rulers of the collector or the degeneration into different political regimes, which is what can happen. And this is something that's been studied in political science for many years. Yeah. So to explore this particular proposition, Ober came up with a thought experiment. It's a thought experiment addressing a particular question of social order, which was, how is it that a human community can reliably realize the benefits which are derived from social coordination cooperation without actually submitting to a ruling oligarchy or an autocratic monarchy, no matter how benign this philosopher king might be. So the premises of this thought experiment were threefold. First of all, he assumed, let's take a normal distribution of people with respect to their preference for avoiding tyranny of some kind. Yeah. So whatever other characteristics they might have, you can imagine taking a distribution of people with respect to their preference for not living in a tyrannical regime. And then you take the ones that are most resistant to avoiding tyranny, and you say to them, right, okay, here's an island, here's a city-state like Athens, this is yours. Yeah? Now go ahead, define your own political regime. And then the thought experiment goes on to say, well, they would do this in 3 stages. In the first stage, they will found it, so they will agree who is and is not a member. The second stage, they would agree on the basic rules of participation, the legislation, and their entrenchment. And in the third stage, they will then actually sort of operate the post-foundation rules, which is how the system actually operates in practice and how they need to change it in order, excuse me, to avoid this tyrannous outcomes. Of course, this was a thought experiment. You can't really sort of take a distribution of people and see how they go, or appropriate an island and say, right, there you go. Although, curiously enough, at one point they did come close to this with something that was called the Shantung compound, which was an enclave that was put together for European and American citizens in China, in Japan in the Second World War. Yeah? And they were basically told, here's a compound, you've got to live in here and carry on, make your own rules. Yeah? So there's one example where the thought experiment did actually come, was actually practiced, but I mean, probably don't need those conditions. So what can we do instead? Well, of course, actually, we can do this sort of thing with multi-agent simulation instead, and that is what we did. So what R wrote was a simulator called SimDemopolis, which basically involved a specification implementation of what is known as an electronic institution. So this is just a specification of a set of rules which our software agents are going to implement. So this specification, which was written in Prolog, so the nice thing about that is that it is its own implementation, had 3 sections. These sections were the facts, the rule overview, and then the actual codification of the knowledge of these rules. The facts included 2 different sorts of facts. So this kind of goes to Wittgenstein when he says the world is a set of facts. Yeah, but Wittgenstein didn't, although he did say that this was in the Tractatus Logico-Philosophicus, that facts could be either true or false, which is fair enough. He also didn't distinguish these things which, in a construction of shared reality, we distinguish between brute facts and institutional facts. So brute facts are those facts which are true by physical reality, and the institutional facts are those facts that we agree are true by convention, basically. So we have to distinguish between these 2 things. In the rule overview, we had 2 different types of rule, which were actually taken from Peter Suber's Game of Nomic, if you've ever come across this. So you had immutable rules which could be changed, and immutable rules which could not be changed, unless you had a process where you could say, I propose to make this immutable rule mutable, it gets voted on, and if you agree, then you can make it mutable, and vice versa. But essentially, the immutable rules were concerned with what we might call constitutional choice. So this was how you actually affect the constitution of the rules themselves. So this was all to do with the enactment, dependent, repeal, and change of rules, issues of citizenship, and issues of punishment, i.e. How you would sanction agents for misbehavior. And then there are a bunch of mutable rules which are concerned with how you actually operate the system itself. And these were to do with participation, who occupies certain important roles in the community, who has access to certain important resources, how things are distributed, and also how you would monitor and report things when they went wrong. So this would be a minor claim against somebody. Now, once you'd define those, these are effectively the parameters, then the knowledge codification would actually do those. And this would actually precisely define the rule in terms of how it is invoked, what rules were involved, what powers they had. And these powers are this institutionalized power to create these institutional facts, yeah? And what degrees of freedom there were, so what values different parameters could actually take. So now we have a nice setup for our for a simulation of SimDemopolis. So we can assume that we've got a bunch of agents and they would prefer to avoid any form of tyranny. Yeah? So now we can run some experiments of some kind. So what we did is that we set up a multi-agent system of some kind. We've got a set of agents and they're connected together in a social network defined as a random graph on the set of agents. So we have a set of nodes in a network and a probability P that there is a connection between any two of these nodes. Okay, and we'll see how we play around with different networks in the experiment. Yeah? And then the way that it would operate is that we would have multiple rounds of an operational choice game. So there would be a linear public good game that they were playing, so that the agents were supposed to contribute a certain amount of their own endowment of resources to a common pool, and then that would be distributed amongst them. And then every now and then, there'd be an invocation of the collective choice rules. You know, for example, we're going to see how much the agents themselves were actually participating in the application of the rules. And what we wanted to do is to see, well, is it possible that the agents could avoid, we call it this entropic tendency towards various forms of tyranny, whereby entropy here, I mean a process of seemingly inevitable gradual degeneration, because the tendency would be for these systems to lapse into oligarchy through lapse into tyranny through various different forms. Yeah? The different forms of tyranny are as follows. There's oligarchy, which is the rule by a clique. There's autocracy, which is ruled by just one. And then there's majoritarian tyranny, which is ruled by largest number. And so we're going to see how it is that we can avoid this slide into these different forms of tyranny through the way we do civic participation, legislation, and entrenchment. So I'm going to take you through these experiments now. So civic participation one, we're trying to avoid oligarchy. Yeah? So taking a line from Ober's book, he says that all citizens have a duty to share in one way or another in the making, adjudication, and enforcing of the rules. Yeah? So we are going to interpret in one way or another as equally in this particular case. And an equal share of the roles that you have to perform is going to be computed using the Gini index, which is actually a measure for equality of income distribution, but we're going to use it as a measure of the amount of work that you put in by occupying one of the roles that is needed to execute these rules or these protocols. And the participation rule involves opinion formation and voting. Yeah? So what the agents are going to do is that they're going to form their own opinion on whether or not the roles have been distributed equally. Yeah? And then they're going to exchange those opinions with the other agents to see if others agree with them. And then they're going to take a vote effort in the performance of these roles has been fair or not. And these are some results here. Probability of connection. This is a fully connected network, so the probability of there being any connection between two agents is 1. And this is a sparsely connected network, so the probability was 1 in 6. Yeah? And each row in these tables indicates one run of a randomly generated multi-agent system. And each point in the row is whether they take they think it's unfair, the distribution effort. And if it's blue, and look, although this is a couple of years old, I've chosen the colors of the Swedish flag. So, if it's blue, it means that they think it's fair. And if it's yellow, they think it's unfair, and they take a vote. The vote says it's unfair and that they should reorganize the rules. And so this means that they run another protocol to reassign all the roles that are being used. Yeah. And what you can see in any one run is it starts off with a period of where they think it's all fair, and then they think it's unfair, and so they go through a period of voting to change it, and then it settles down again, and they think it's fair for a while, and then they shake it all up again, and this keeps on going. So what we see is that even down to a relatively low level of connectivity, here's just a 1 in 4 chance of being connected. We actually get what's effectively a quasi-stable system. And this is sort of like from cellular automata. What happens is that it goes through a period of stability, and then it's unstable for a while, and then a period of stability is restored, but with a different set of values for the control parameters, and that stays like that for a while, and it caps on. And so it's not until you get down to a 1 in 6 chance that we see these things breaking up, and the agents sort of thinking that it's relatively fair when it's not. Yeah? And this is quite interesting because Ober basically said that this level of connectivity supported observations about how democratic federalism was actually applied in classic Athens, because they didn't all apparently just go down to the agora and start voting. They sent delegates according to districts and so on. Yeah. So 1 in 3, 1 in 4 is about the likelihood of the connections in the social network. Now, how is this avoiding oligarchy? Because it's possible that you can game the participation rule. So one thing that you can do is that you can refuse to accept a role. So basically you get other people to do all the work while you're free riding, by having more time to yourself to do whatever foul and depraved things that you want to do. Yeah? But what this can result in is the emergence of oligarchic tyranny by default, because if the agents don't participate, then there's a small group that just takes it over by default. The other possibility is that you can refuse to resign from a role. So this means you can grab power for yourself. And this is the emergence of an oligarchic tyranny by intention, because an agent refuses to let go of the role. Yeah? So what we did to do this is that we introduced a citizenship tendency, which was a probability that an agent would be likely to refuse to accept a role, and a probability that an agent would refuse to release a role when it was told to do that. Yeah? And then we introduced this minor claims protocol that I mentioned earlier on, that if an agent detected that another agent was refusing to let go, it could be reported, and then it could be forced to let go. Yeah. And here was the result. I ran it with exactly the same distribution of agents with the citizenship tendency, same number, same other characteristics, just that tendency. And what we saw without the minor claim protocols, you could get an agent that would take a particular role and then not let it go. Yeah? But you'd be able to see that as an outlier in the system. But when we had the minor claims protocol, so that this behavior would not just be detected, but you could also do something about it, those outliers disappear, and they were prevented from this sort of power grab. What this means is that, you know, the more that you increase the connectivity, it actually increases the opportunities for misdemeanor, but also increases the likelihood that someone's going to observe you for doing it. But what was quite interesting is it actually showed up the limitations of the Gini index and the limitations of metrics themselves. So it turns out with the limitations of the Gini index, you can't pay attention to the rate of change of the Gini index, because you can give it a certain, measure it, it's got a certain value. What I found is that you could make one agent, vastly more self-benefiting, highest income, most number of times in a row, and it would barely alter the value of the Gini index at all. And so this is a problem that we have, for example, with income distribution at the moment, is that people are pointing to the fact, oh yeah, but the Gini index has hardly changed at all. But the reason for that, of course, is that the full 1% has actually increased its share of the income massively, but actually that doesn't affect the Gini index very much. And the second one, you've got to know what it is that your metrics are actually measuring. So our metric did actually tell you when one agent was grabbing power and not letting go, but it couldn't distinguish from an agent not getting power because it was free riding, or whether an agent was not being participating properly because it was just not very well connected, and so none of the agents were voting for it to actually accept this role. And it's a bit like H index, but the other way around. If you see somebody with a very high H index, it's perfectly, you can ignore that because there may be other explanations for why they have a high H index. I mean, for example, it has been shown that high H index is correlated with network centrality. So it could just be that they're popular as well as that their science is good. So what you're really concerned about is when actually the H index is much lower than what you expected, because there may be an explanation for that you are interested in. So you have to be very careful about understanding what it is that your metrics are actually telling you. The third thing here, the civic participation against oligarchy, is that we did this role assignment bias. So what we did is we looked at the node that had the most connections to other nodes, and then every time there was supposed to be a shake-up, it would redirect, so it reassign itself to be the director, and then rather than actually sort of doing the votes, it would appoint its own social network to these other roles, and then carry on. And what we can see here, here's the same sort of runs going across here. In these two, we see that actually the director was appointed itself, was fortunate enough to get voted in right from the start. And you see that nothing changes. All the agents can actually see that there's something wrong. They vote for there to be a change, but the director just reappoints itself, reappoints its mates, and so they carry on. And as soon as this agent manages to get hold of that role, the system basically sticks. And there's this unfairness that propagates. The agents keep on voting for change, but you can't stop it. And there's two observations about this again. One, we need the outgroup to be connected in order to be able to detect it. So you've got to, in the first place, so the fact is they can actually see that there's something going wrong. They just can't stop it at this point. But at least because they're connected and they're talking to each other, they can detect it. But just this participation rule can't actually stop this sort of behavior. So it's really important that you know what the rule is for and why citizens do need to comply with it. Okay, the next experiment was about how the legislation actually deals with the risk of autocracy. And this is how we can change the legislation by enacting and repealing legislation, do transmutation, so we can change the rules. And basically, the experiment here involves the delegation of political authority from the demos, the people, to a representative. But then suppose the representative starts acting in a way that is in favor of its interests and not in the interests of the demos. Yeah? And so basically, you're playing this game. The representative can either violate what it's supposed to do, in which case the demos can revoke it, or they can choose not to revoke it, in which case representative gets huge benefit, the demos gets nothing. Or the representative cannot violate it, and there's no revocation, and everybody benefits, demos most of all. But it's not a good idea if the representative doesn't violate it and you do revocation. And so this is what we do. When we assign this representative a probability of violating the rules, so it takes more of the resources to itself, and if it gets away with it, then it increases its chance of violation. Here's what we see. So the green line here, if you can see it on your screens, I don't know, shows the probability that the representative will violate the rules. And what it's doing is it's taking more resources for itself and distributing less and less to the others. So its payoff is going up much more. As we can see, the distribution payoff, this change in the Gini index, as I said, this is the dotted black line here, it doesn't look very great. Yeah. So it doesn't look to be a big change. But this red line here, what was fascinating when this happened, the agents are there gossiping amongst themselves, not thinking it's fair. And at some point, the opinion formation reaches a tipping point, and suddenly more and more of them think that it's unfair, and they vote against to revoke the thing from the government, from the representative. Yeah. So one of the nice things about this is this idea of bright lines and the use of immutable rules for repealing mutable rules. And the really nice thing about this was that because it's Prolog, I got this plug and play governance. So basically I could just take out a rule and I could plug another one in and carry on. I think Prolog's cool, okay. And I know this is a bit of a classical old-fashioned notion, but Prolog's cool. And the last experiment was this risk of majoritarian tyranny. And here I implemented SimDemopolis, where I assume all the agents have a preference for non-tyranny, but assume another polarized preference as a type A for type B. Yeah? And what I do is I play one of these partial good games. And in these partial good games, it's possible for some of the agents not to show up when they do the distribution. So you play the partial good game with only a subset of the number of agents showing up. And then you play an elimination game. You say, well, you guys didn't, someone didn't show up. You don't deserve to be here. We'll throw you out. So effectively now I've moved citizenship from being an immutable rule to a mutable rule. And these were the results. Yeah? You had to have a 60% participation to actually apply the elimination. But it turned out that under these conditions, one type could eliminate the other. And when it started off with an equal number of each type, you basically got an equal number of A's eliminating B's or B's eliminating A's. But I only had to change it slightly, just the proportion of 51 of type A to 49 of type B, which was enough to almost guarantee that the A's would eliminate the B's. And when I changed it so the quorum, to be able to eliminate something, you actually had to have 2/3 majority to be able to do anything. Still, it wasn't, when there were equal number of A's and B's to start off with, it wasn't clear which one would win out. But again, just a small change in the number of type A and the number of type B were enough to be almost certain that the type A's, it would take them a bit longer than with a lower quorum, but they would eliminate the type B's eventually. So a couple of observations about this. You need to have this separation of allocation of resources issues should be mutable from the way that you deal with citizenship, which should be immutable. Yeah? And really is important to protect minority rights and recognize diversity. Thank you. So I believe I've got about another 5 minutes to run through the implications of this, if that's okay. Yeah. And it's this list here. I'll go through each of these in turn. So the implications for engineering socio-technical systems, this is where the democracy by design comes in. So we think this is an instance of value-sensitive design, which is trying to say, so value-sensitive design says that, you know, rather than functional and non-functional requirements, we need to actually consider these qualitative human values as primary design requirements. And probably most of you have heard of privacy by design. That's the most usual instantiation of this, where you actually say, well, okay, what we're going to do is design our systems with privacy built in, not build the system, then try to bolt privacy on top. And it's the same with, in effect, democracy. There's no point building your system and then thinking it will work out nicely and we'll just bolt the democracy on top. We actually have to build these socio-technical systems with democracy built in to start off with. So some of you will have noticed that while I was going through those experiments, there were these P1s, P2s, and so on. Yeah, and basically, these are the observations that fed into these 8 foundational principles of democracy by design. That you have to prevent your democracy from collapsing rather than letting it collapse and trying to reinvent it. You shouldn't assume that democracy is the default, or once you're in a democratic end, in democracy, that's going to be an end state. You do have to worry about the transfer of power, and this is one for our American friends, of course, coming up to November. You can't make any compromises on the democratic processes. You need to have visibility, inclusivity, transparency, and accountability. You need to recognize that there's independence that you get from diversity. You need the diversity of knowledge, for example. You do have to educate people in the recognition of the pro-social benefits while we have this. And you do need some kind of procedural evaluation and reflection. But you have to understand what it is that the metrics are telling you, and that just because you take a vote, that doesn't end discussion about values. For modeling, you know, what this sort of thing is telling you is, you can make some theories based on some assumptions like rationality, and this will make predictions. For example, the tragedy of the commons, where this was where people will deplete a common pool resource in the short term, even if it's no one's interest in the long term. But actually what we can do is that we can build models of these things. This is a fairly precise and testable model of the theory of politics, and we can use that to investigate behaviors and trajectories of political systems. Yeah. But it's also telling us quite a bit more about reflection and metagames. And this is a comment that Ostrom made. Yeah. I mean, if you set up your game so that you will see, so that selfishness is rational, which is essentially what the prisoner's dilemma does, you will see selfishness as rational behavior. If you set up your game so that cooperation is the rational product, you will see cooperation emerge. And so your problem is, when you are faced with one of these collective risk dilemmas or a common pool resource problem where selfishness is a rational action, then you need to work out what it is the metagame that you put on top of that to make sure that cooperation can emerge. The other thing was this really interesting thing about implications for historical political science, which is why it was so much fun with working with Josh Ober on this. You know? Because he got a lot of feedback from it and insight. Yeah. So one was that, you know, that he could actually have documented classical processes which were sufficiently accurate that I could specify an algorithm and make it run. One of the things that he was really interested in as a historical political scientist, you know, Usually they have to work in the domain of counterfactuals, saying ask what if, yeah. But now we could do simulation, yeah. And so that he could actually ask me questions, well, what if we change this parameter? What if we do that? And I could run it and show him what would happen. He found this really quite interesting. And the third thing, I mean, from his point of view, was that it actually reinforced ideas that he had, that learning and innovation was endogenous within classical Athens. They weren't actually, there wasn't some external authority that they were consulting, that was telling them what to do. And the oracle wasn't, you know, that they were consulting wasn't giving them finalized answers. All the learning and innovation that they were doing to make their democratic processes work was coming from within, because I would start these simulations going, and I wouldn't interfere with it after that. There was nothing outside the simulation. He thought this was an interesting verification of claims that he'd been making in his books for some years. There's another thing that's about the public understanding of democracy. As I don't know about you guys, but I'm often encouraged to engage in public understanding of science and technology. Yeah? But actually, I think there's a corresponding obligation, shall we say, on our colleagues in departments of political science, that they should be going out and doing public understanding of democracy, for example, yeah, and explaining to students and in other departments and in schools about why it is that democracy is so important, and why responsible knowledge management is important. So not lying all the time to your citizens, why civic education and critical thinking is important, what civic dignity is in, why that should be maintained, and so on. There's also a lesson for us to learn. I don't know whether it's like this in UK, in Sweden, but in the UK we do seem to be going a bit top heavy on the management side of things, yeah. And so we have a lot of centralized metric-based bureaucratic managerialism rather than freedom of to maneuver for ourselves. Yeah. This work has sort of set off a line of research which we're calling computational comparative politics, which is using algorithmic models to study the trajectories of political regimes and do this sort of comparison, for example. Yeah? But the nice thing that comes out of this is the opportunity to specify algorithms that we believe will produce just and sustainable societies, regardless whether these algorithms are implemented in carbon or silicon or in both, as we're going to see, we think, in socio-technical systems. And I'm going to finish off on, I've tried to avoid it, yeah, but I mean, lest you run the risk of a Swexit or something like that. Yes. One of the things that went wrong with the Brexit referendum, yeah, the essence of democracy, at least, is this confluence of multiple, transparent and inclusive knowledge processes that allows a diverse population to satisfy their values and avoid tyranny. And if we look at what happened during that referendum, we had a total breakdown. Well, I thought so, we avoided it then, but given the recent election, I don't think we have. But all of the things that we've been talking about basically have been undermined or discarded, so that there's a ruling oligarchy, this dismissal of expertise, this invocation of majoritarian tyranny and a single one-off, forever, unmutable, unchangeable, timeless and unquestionable vote. The way that civic dignity has been undermined. Ober says that dignity is maintained when a population is not lied to and they are given enough information and knowledge, correct information and knowledge, to make a decision, and not if they are fooled into making a decision that is against their best interests by being given the wrong information. And so on. Civic education in the UK has been grossly undermined. Yeah. And just this idea about you might be able to change your minds and make expressions of dissent. And it turns out that disobedience is a really, really important property of democracy, and being castigated as an enemy of the people because you disagree with something is really not the way to go. So in conclusion, I'm going to say why this stuff matters, partly because it's going to be involved in the design of socio-technical systems, which is my next seminar in a couple of weeks' time, and partly because we'd all like to live in a nice basic democracy with some nice liberal values thrown in. But it turns out this type of political regime is not the fault. It needs protection if you're going to preserve it, and it is incumbent on all of us to get involved in that. And I'll leave you with the words of Ariel Dorfman from Chile, who said, "Do not cry to tomorrow for that which you did not have the courage and wisdom to defend today." And that's it. Thank you very much.